Hello students, this is Mr. Bornheimer. Today we're going to talk about how you find the surface area of a cylinder. And so here in front of us we have a cylinder. Okay, so here is the bottom base of the cylinder right here. And here's the upper base of the cylinder. And then we have the cylinder itself, which is this vertical looking tube. Now, the surface area of a cylinder is the outside. So if you think about a can, it's the label, the top, and the bottom. And so we're trying to figure all of that out. The nice thing about a cylinder is that if all cylinders share very similar properties. So unlike prisms, which can have different shaped bases like triangles or any sort of polygon, rectangles, squares, hexagons, etc., a cylinder will always have a circle for its bases. And this makes calculating surface area of a cylinder in many ways easier. Now, just like when you're working with a circle, however, because we're working with a circle, you are going to be using values and equations that involve the use of pi. So make sure that you know either where the pi key is on your calculator, or today we would want you to remember that pi is basically the equivalent of 3.14. And so at least for our calculations. Technically, it is an irrational number. It goes on forever, but for our purposes, we can use 3.14 for our calculations. So the first thing we're going to do is we're going to look at this cylinder in terms of its net. So we see here a couple things, okay? We see first and foremost that we have a base here. Okay, so there's one of our bases. I'm shading that in red. We have another base, which I'll shade in blue. And these are the same exact size. You might be thinking, well, Mr. Bornheimer, they have different numbers. That is true. But over here in the left red base, I have indicated that the diameter, the special chord that goes from the middle one side to the middle of the other of a circle through the center point, the diameter is 7. Half of that would be a radius, and that's what you see down here on the blue base. That's 3.5. So these are units. Now, these two circles are congruent and parallel. Remember that the two bases of a cylinder or a prism are always congruent and parallel. And the part of the can or cylinder that the label would go on, that's this giant rectangle right here. It would get folded kind of around into like a tube. And so that, notice the 6 here, okay, is the exact same as the height of the cylinder. Okay, so this 6 actually represents, I think this is a very important point to make, this represents the height of the cylinder. And it's really that distance between the bases. Okay, so if you were to fold one base here and fold another base here, right, the distance between those is this height right here. Okay, so we need to kind of understand what we're looking at here. Now, there's lots of numbers here that are very useful, particularly, and all of these numbers are useful. The diameter is useful. The radius is useful. The height is useful. But there's some other pieces of information we're going to have to figure out. For instance, we're going to need to figure out the area of these bases or these circles. So we're going to need to revisit the area of a circle. We're going to need to visit the circumference of a circle. So what is the circumference of this circle? That's the distance around the outside edge. So two things we're going to be revisiting here will be area of a circle and circumference of a circle. So those are two things that we need to revisit. Now, to find the surface area of a cylinder, you need to first find the area of the base. So again, remember what we said about area and circumference. The area of the base is going to be this formula right here. Area equals pi r squared. That means we're going to take the two r values and multiply them by each other. Okay, so r squared. The second thing we're going to do is we're going to find the circumference of the base. So notice here that the very first things that we do with this cylinder are with the base. We're finding the area and circumference of the base. We're working only with the base. And the only thing we know about the base is either its radius or its diameter. And if you know one, you know the other. The circumference formulas are here. They are technically the same. One has radius, one has diameter, but ultimately they are technically the same. They'll both get you circumference. It just depends on whether you're working with the radius or the diameter. Notice all three equations in the red boxes involve pi. Okay, so we have pi here and here and here. And that means that we have to be mindful of that 3.14. It's going to be part of our calculations. Okay, so for this particular circle, let's do this. Let's find the area and the circumference. So the area is going to be pi r squared, and we want to do it for the base. You may be thinking, well, don't we have to do it twice because there's two bases? Not necessarily. Remember, the bases are congruent and parallel. That means that if we do it for one base, we've done it for both because the bases are congruent. They are the same. They have the same measurements. So if we need them, we can just double what we find. So to solve this, we would say, okay, area equals pi r squared. Area equals pi. And then the radius is 3.5 squared. Okay, so here's our calculator. We're going to take 3.5, and we can either hit the squared, the x squared button, or we can just multiply it by itself, 3.5, and we get 12.25. So I'm just going to take that off there. So that's going to be pi times 12.25. Now, pi is 3.14. So we're going to go ahead and simplify this so that it is 3.14 times 12.25. Bring calculator back over. 12.25 times 3.14, and we get 38.465. And we'll round this to 38.5 units squared. So we're not going to necessarily do anything with that just yet, but that's the area of the base. Okay, so that was the step number 1, find the area of the base. So anytime you're working with a cylinder, first thing you do, find the area of that base. Okay, so I'm going to go ahead and I'm going to take all of this calculations and I'm going to move it. Okay, the next thing that we are supposed to do is find circumference. The equation for circumference is pi d. You might be thinking, well, why don't we just use the r equation? Well, we could, but pi d is simpler, for one, and they give us the diameter, and so we might as well use it. So we're going to proceed with this. Circumference equals 3.14 times 7. So bring our calculator back over. 3.14 times 7 gives us 21.98. We're going to round that to 22. Now, notice that I put only units here. This is an important distinction to understand. I'm going to put units here. When you're working with circumference, that's distance. That's like if you were to walk on the ground around the outside of a circle. Okay, area is the amount of space inside that circle, so that's units squared. But circumference is just units. Okay, so now I've got that value. I've got circumference. Let's move that down here as well. Okay, the last thing in our list of things to do here is plug everything into the surface area equation. So you're going to want to write down this equation for surface area. It looks way more complicated than it is. Okay, so basically you are going to, and if you'll follow along with me here, you're going to take 2 and multiply it by that base area that we found. Then you're going to add everything that's in the red. And in the red is the height times circumference. So this really isn't too bad. You're going to multiply the area by 2, and then you're going to take the height and multiply it by circumference. And so you're really doing two different actions and combining them together. What's nice about this is if you follow this, you've got everything, right? You're just going to be plugging in a bunch of numbers. So I've got over here area, circumference, height, area, circumference, and height, and this number 2. So let's plug everything in. We're going to have 2 times the base area, 38.5 units squared. We're going to add to that the height times circumference. The height is 6, and the circumference is 22 units. And the height is 6 units. Now we go ahead and multiply and add these together. So 2 times 38.5 is going to give us 77. So I have 77 units squared plus 6 times 22 is 132 units squared. I add those together and I get 209 units squared. So the surface area of this cylinder is 209 units squared. Now, again, this seems all very complicated when you're looking at the math and you're like, oh man, I can't do that. I can't plug all those numbers in. You absolutely can plug all those numbers in. You're more than capable. You got to break it down into steps though. And again, it's not too bad. Find area, find circumference, plug everything into this equation, which I'm giving to you and you will have access to, and solve. The obvious thing you have to be careful about here, and the reason why you're going to see these brackets, is because you want to break this into even pieces here in the equation. So you want to do the green first, then do the red, then add it all together. Okay? What you don't want to do is forget the brackets, because then, because of order of operations, things can get very, very messy. So let's go ahead and let's do this with another example problem. So what I'm going to do here is I'm going to copy this equation because we need it. And we're going to come over here to this particular problem, like so. Let's go ahead and read. There is a grain silo that needs to be repainted. A grain silo is a place where farmers store lots of grain, oftentimes corn, and it can dry and be in that silo so that farmers can sell it as it's needed. Okay, because when you harvest all the corn at one time, it's not always needed, and so sometimes it has to be stored away in these very tall silos. And if you've ever been out driving in the country, you've definitely seen silos. So there's a grain silo that needs to be repainted. Only the vertical face of the silo needs to be painted. If the silo has a radius of 2.5 meters, okay, notice that here, how many square meters need to be painted? Now, what's really fascinating about this particular problem is that there is this indication that you don't actually have to do as much work in the problem. Only the vertical face of the silo needs to be painted. Only the vertical face. So if we were to take a look at this, that would be this area right here that wraps around the silo. Only that needs to be painted. Not the top area here or that bottom base. Only that vertical area needs to be painted, which means that we're not going to need all of our surface area equation. So you might be thinking, well, how do I know which equation I need? Okay, well, that's a good question. You've got really two choices here, right? You've got this first part here, and you've got this second part here. Well, this green part includes the base areas. And if you think about that, that's this area here at the bottom and this area here at the top. And that is not what they're asking us to calculate. That doesn't need to be painted. That's inside the grain silo. What we need to paint is this outside area, this area on the vertical outside area of the silo. And so that is actually going to be this second part over here. So for our purposes, and in this equation, we will not need to use this first part of our equation. So the surface area that needs to be painted is going to be the height times the circumference of the base. And I wanted to show you a problem like this because you may need to modify an equation to fit the problem. So in this particular case, we don't need to find the full surface area of a cylinder. We only need to find the vertical surface area, that part of the silo or that part of the cylinder that wraps around. If we go back here in the net, that would be this rectangular area. That's all we're really technically finding. So let's find these two things. Again, we need to find circumference. So circumference equals pi d, or circumference equals 2 pi r. In this problem, they give us radius as 2.5. So we can use this equation here. Circumference equals 2 pi r. Circumference equals 2 times 3.14 times 2.5. Grab our calculator. 2 times 3.14 times 2.5. And we get 15.7 units. So surface area equals height times 15.7 units. The last piece of this puzzle is the height, and I purposefully did not include that at the beginning of this problem because I wanted to focus on understanding the problem as a whole, and that means that we are only going to be solving for part of that total surface area of the cylinder. So the height of this particular grain silo, okay, if you think about a grain silo, it's as tall sometimes as 2 or 3 buildings, and a building on average can be anywhere between 10 meters tall. So we're going to say that the height of this grain silo is 30 meters. That'd be a very tall grain silo, very tall. Okay, so surface area equals 30 meters times 15.7 meters. 30 times 15.7, 471 meters squared. Surface area. Area always has units squared. And that would be the end of this particular problem. So, to recap, anytime you're starting a surface area problem, if you have to find the total surface area, you start by 1, finding the area of the base, 2, finding the circumference of the base, and 3, for a cylinder, applying this formula right here. If you only need to find the partial surface area, then you need to determine whether or not you're looking at the height of the can or whether you're looking at the tops and bottoms of the can, okay? So this part over here deals with height, okay? We call that the vertical surface area. And this part over here deals with the base areas. We call that the horizontal surface area. So we have height and the base areas that we have to worry about. So this is how you find the surface area of a cylinder.